Hydrogen could be more effective at decarbonizing steel manufacturing if the process was better understood. To learn how to effectively use H2 to decarbonize the steel industry, hydrogen research needs to be conducted to find out and understand exactly how hydrogen-based direct reduction works in the manufacturing process. A Binghamton University professor recently received a $470,700 grant to research the process on an atomic level. Traditionally, smelters produce steel by removing oxygen from iron ore through a carbothermic method that combines iron oxide with carbon and intense heat. In recent years, experimental green steel projects that use hydrogen instead of carbon-intensive manufacturing have been popping up as the steel industry seeks to lower its emissions to meet government climate targets. Binghamton University professor Guangwen Zhu, who received the grant from the National Science Foundation to conduct the steel-making hydrogen research, explained that when looking at the reduction of iron oxides with hydrogen, it looks quite simple. You produce iron and water, Zhu said. But in reality, it's actually quite complicated because the reaction involves several other intermediate solid phases. According to Zhu, it is necessary to look at which direction can be improved further to achieve better efficiency. Zhu, an associate director of Binghamton's Institute of Materials Research and deputy director of the Materials Science and Engineering program, has been studying metal oxides for over a decade. Recently, he teamed up with the Brookhaven National Laboratory and other collaborators for 2 major studies of oxide reactions in real time. These studies offered new insights into how the process works, as well as how the reactions can be controlled. Zhu and his students will use Brookhaven's equipment, including an ambient pressure X-ray photoelectron spectroscopy and environmental transmission electron microscopy, to study potential pathways to lower iron from iron oxide at temperatures above 1,000 degrees Celsius. Through their hydrogen research involving the steel process, Zhu and this team want to provide a fundamental understanding on the basic chronology of the reaction process and its complicated transformations. Once we know that, Zhu said, we can play with factors like the amount of hydrogen, the pressure, or the temperature to optimize the process. Over 2 billion tons of steel is produced globally every year. Steel is not only one of the world's most important industrial materials, but it also accounts for 7–11% of all human-made greenhouse gas emissions. To put this into greater perspective, if the steel industry was a country, it would rank as the 5th largest producer of CO2 emissions in the world. I think this project comes at the right time, Zhu said of the hydrogen research. There's a lot of interest from the research community and from society because of the need to reduce greenhouse gases. Thank you for joining me today. Don't miss our awesome new ebook. Make sure to hit subscribe and grab it now on the link below. Don't forget to leave us a comment. Thank you.